Now, how does it work? How come it's so successful? Science has built-in error correction mechanisms. Because science recognizes that scientists, like everybody else, are fallible. That we make mistakes, that we're driven by the same prejudices as everybody else. And so there is self-correcting machinery built into the structure of science. There are no forbidden questions. Arguments from authority are worthless. Claims must be demonstrated. Ad hominem arguments about the personality of somebody who disagrees with you are irrelevant. They can be sleazeballs and be right, and you can be a pillar of the community and you can be wrong. It's not, being a sleazeball does not guarantee that you're right. But the correlations are very weak. If you take a look at science in its everyday functioning, of course you find scientists run the gamut of human emotions and personalities and character and so on. But there's one thing which is really striking to the outsider, and that is the gauntlet of criticism which is considered common, de rigueur. So the poor graduate student at his or her PhD oral exam, subjected to a withering crossfire of questions which even sometimes seem often seem hostile, from the professors who have PhD or failure in their grasp. And the students naturally are nervous, who wouldn't be? And they've prepared for it for years. But they understand that at that critical moment, they really have to be able to answer questions. They have to anticipate questions. They have to think of, where in my thesis is there a weakness that someone else might find, because I sure better find it before they do, because if they find it and I'm not prepared, I'm in deep trouble. You take a look at scientific meetings with people yelling at each other and the chairman trying to call for order. You find university colloquia in which the poor speaker has hardly gotten 30 seconds to present what she or he is saying, and suddenly there's questions, interruptions from the audience. You take a look at the publication conventions in which you submit a scientific paper to a journal, and it goes out to anonymous referees whose job it is to say, did you do anything stupid? If you didn't do anything stupid, is there anything in here that is sufficiently interesting to be published? What are the deficiencies of this paper? Has it been done by anybody else? Is the argument adequate, or should you resubmit the paper after you've done the actual work that you are here speculating on? And so on. And it's anonymous. You don't know who it is. You have to rely on the editor to send it out to experts who are not too cruel. This is the everyday expectation in the scientific community. And those who don't expect it, even good scientists who just can't hold up to the criticism, are in deep trouble. Why do we put up with it? Is that we like to be criticized? No scientist likes to be criticized. Every scientist feels an affection for his or her ideas and scientific results, like children. And somebody attacks them, you feel protective. Wait a minute, this is a really good idea. Don't attack it. But that's not the way it goes. The idea is that the ideas that don't work, throw them away. Don't waste any neurons on what doesn't work. Devote those neurons to new ideas that better explain the data. Be willing to surrender your own ideas. There is a reward structure in science which is very interesting, which is that our highest rewards go to those who disprove the doctrines of the most revered scientists. there's a bonus for proving the greatest among us wrong. So Einstein is revered not just because he made so many fundamental contributions to science, but because he found something that Isaac Newton missed. And Isaac Newton, surely the greatest physicist before Albert Einstein. Now think of what other areas of human society have such a reward structure in which we revere those who prove that the fundamental doctrines that we have assumed are wrong. Think of it in politics, think of it in economics, think of it in religion, think of it in how we organize the society. It's exactly the opposite. There we reward those who reassure us that what we've been told is really right and don't have any concerns about it. And that's why we've made, or it's at least a fundamental reason why, we've made so much progress in science and so little in these other areas. Another key aspect of science is experiments. We experiment. Scientists do not trust what is intuitively obvious because intuitively obvious gets you nowhere. That the earth is flat was once obvious. I mean, really, obvious. Obvious. Go out in the flat field and take a look. Is it round or flat? Just, don't listen to me. Go prove it yourself. That heavier bodies fall faster than light ones was once obvious. That blood-sucking leeches cured disease was once obvious. That some people are naturally and by divine right slaves was once obvious. That the earth is at the center of the universe was once obvious. You're skeptical? Go out, take a look. Stars rise in the east, set in the west. Here we are, stationary. We see them going around us. We're at the center. They go around us. The truth may be puzzling. It may take some work to get to. It may be counterintuitive. It may contradict deeply held prejudices. It may not be consonant with what we desperately want to be true. But we are not the measure of what's true. We have a method, and that method helps us determine not absolute truth, only asymptotic approaches to the truth, never there, just closer and closer, always finding vast new oceans of undiscovered possibilities when we have made tiny forays into the island on this great sea of unknowing. Experiment, cleverly designed experiments are the key. Many decades ago, in the 20s, there was a dinner at which the physicist Robert W. Wood was asked to respond to a toast. This is the time when people got up, made a toast, then said, okay, now you respond. And nobody knew what they'd be asked to respond to, so it was a challenge to quick-wittedness. And in this case, the toast was to physics and metaphysics. Now, by metaphysics was meant something like philosophy, truths that you could get to just by thinking about them. Wood took a second, glanced around him, and answered along these lines. He said, the physicist has an idea. The more he thinks it through, the more sense it makes to him. He goes to the scientific literature, and the more he reads, the more promising does the idea seem.